Hello and welcome to Lights and Clockwork. I recently did a few videos on making an R2D2 in a weekend. In those videos I made a little transmitter and a little receiver. Well, the transmitter is very vulnerable, the switches keep falling off, keep messing about. This is also kind of vulnerable with the MP3 play sticking off. So I think it's time that we moved on and started making PCBs. Now this is going to be a two-parter, so it's going to be part 4 and part 5. So do stick around for both this one and the next one. So I'm going to start with the breadboard transmitter. You know, it's quite simple design, so it shouldn't take us too much to convert. And after that, we'll also look at the receiver prototype board and also convert that to a PCB while we are at it. So the steps we're going to go through is we're going to use EasyEda to actually create the schematic. We'll then convert that to a PCB itself. We'll upload to PCBWay. We'll then wait for the delivery. We'll finally get the components, solder it on, test it, maybe make some changes to the code, and maybe even make a case, depending on how much time this is taking. Okay, so I've gone to EasyEda, I've created an account, I've logged in, and I am going to stick with the standard version. I've had a look at professional. There's a lot more buttons, a lot more options, but I think if this is your first time, we'll just keep it nice and simple. So I'm just going to create a new project. So again, new standard. I'm just going to give it a quick name. It's going to be just BBR2RX. So we're in EasyEda. I'm just going to click on the common library. There's a lot of components there for sort of getting going, but what we need is obviously this ESP chip. So if I go on library, I'm just going to type in WeMOS D1 Mini, see what comes back. So if I just click on that one, and there we go, it's close enough. You'll notice there's others in other areas, like the user contributed over 1,000, so sometimes you might have to troll through to find the one you want. So I'm just going to place that. So there's our ESP chip. We can see the pins do match. That's important to have a quick check. So the next thing I need is these 6 switches. So again, I'm just going to click on library. I'm just going to type in, I think it was the best way to find it was button switch. So button 6mm, let's see what comes back. Just keep on typing. Sometimes again you have to just have a look through until you find the one that you're happy with. There we go, that's the one I think I want, the 6x6x6. So of course I need 6 of these. So I'm just going to keep clicking. It doesn't really matter where I put them, this is just the schematic. To make things easy for me, I am just going to rotate these though. I'm also going to quickly rename some of these. Now, having a quick close look at this, I've realised that this diagram was the old version where we figured D8 didn't actually work very well. So I am just going to modify that before I go any further. Well, I'm just going to factor that in. So I can now just click on the components and start drawing our connections between the nodes. So this is going to go straight to D7. This one's going to go to D6. So that's our pins connected to the main GPIO. The next bit is to add the ground. Click out that to that side, and now I can just bridge these. Oh, that missed. Now really that schematic is that board, but I want to make a few little changes while we're here, because here I was restricted by the breadboard itself and the wires and knocking them, but now I can start to maybe make this quite a bit better. So one of the first things I want to do is add a capacitor. This will help stabilize the system, the circuit, and makes it much more reliable. So I'm just going to click on the capacitor. I'm just choosing one of these rather than the surface mount. So I'm just going to click that on in place. I'm going to rotate it. I'm just going to bridge this between the 3 volts and the ground. Now it doesn't matter what it says there, because we're still going to solder on our own capacitor anyway, but just to make it a bit easier, I am going to put what it should actually be, which is a 100 UF. There we go, so there's our capacitor. I'm also going to add an LED so that when we power it up, it'll tell us whether it's actually connected or not, just like a Bluetooth flashing light would. So there's an LED. Again, I'm just making sure that I've actually got a 5mm LED selected, not the surface mount ones. I'm just going to put that up here somewhere. Again, doesn't really matter where, other than the fact that I'm connecting it to D0. But I also will need a resistor. So I'm also going to want a resistor. So I've come onto the common library. I'm just going to choose an axial type. Again, doesn't really make much difference because what we put in does. There we go, that should be connected. Obviously this is going to be a 220 resistor, and I can just connect this to D0. Now this is where things get a bit ugly. I should really add a ground plane, but I'm just going to try and keep this really simple. So I just need to connect this back round to the ground itself. And I'm trying to think of the quickest route round. Okay, that'll do. It's not pretty. I could colour code these instead. But I don't think I like that itself. I might change those in a bit. Okay, so I've got an LED, and I'm going to add another component. I want to add a piezo buzzer. Again, I like it to have a little beep or something when it starts up. So if I just again go back onto the library and just type in piezo. Yep, that looks like it should do. So I'm just going to put that up here. Yep, 10mm, that's the usual ones I get. And now I'm going to hook this up to D2. So again, we're just going to do a positive. So this is getting a bit ugly now. Obviously this is not a learn how to be good at schematic course. This is just how to get something working. And I can now hook this up to ground. So I'm going to just jump onto this line here. I mean, that looks really ugly. I'm more worried about the PCB itself, not the schematic. Okay, so I'm going to add one more bit to this, which is I need the pins where I can plug the battery in. So if I just come down here, we've got the male pins. I want it to be 1x2. I can drag this on. And I'm just going to connect this straight to our 5 volts. So we are assuming that you are putting the right amount of voltage in. There's no voltage regulator on this one. This is going to connect to our ground. We could add a voltage regulator, and we might do that on a different circuit. Now, a friend also requests I put a voltage monitor so we can have a little readout. So I'm going to just allow a couple of more pins. So I'm just going to duplicate this, copy and paste, put that there, and again I can just grab this straight from the voltage. Oops, it's not letting me connect. Again, it's really, really ugly. So I'm just going to relabel this PSU for our power supply, and this is just our VM for voltage monitor. There we go. Okay, so that is our schematic complete. This will now do. So if I just press save, I'm now going to go up onto design, convert schematic to PCB. No, I'm not going to check nets because this checks every single pin to make sure they're all connected. I'm just going to say apply, and what it's done is it's given us a board outline, so everything is outside of the board. So if I just drag the ESP up, I'm going to put that approximately in the middle, and I'm slowly going to position these around the board. Okay, so now I've got sort of things roughly placed. I'm really not happy with that piezo. It definitely looks too big for this circuit board. So I'm just going to save this. So it is saved. I'm going to pop back onto the actual part. I'm going to come up here, and I'm actually going to delete it and look for a better one. So if I just go back onto the library, try again. So I'm just going to type in 10mm piezo, see what comes back. Okay, so I've found a different one. Let's place that one in the circuit. Now we'll just connect those nodes back up. Okay, so I'm just going to press save, design, update PCB. Now keep going. Yep, apply changes. Yeah, we'll do. Okay, so it's put our piezo, which is a bit more sensibly sized. going to make a few quick tweaks. Okay, so that's the basic PCB layout for where the components are going to go. We can have a quick look, see what that will look like. There we go, I think that's all right. So that's our, obviously our nice little breadboard now as a PCB, looking very, very similar. So a couple of final touches. I'm just going to click on the design, tools, set board layout. I'm just going to say rounded rectangle, apply. There we go. I prefer if it's got slightly rounded edges. I'm also going to put a couple of little drill holes. So if I do want to mount this to a board, just put these in. Oops, I could have done with making this a bit more symmetrical. I'll do, and obviously I can't fit one there because the piezo's there, so I'm just going to bring this one down and make it offset. Again, please feel free to design your boards how you see fit. Last little step I'm going to do is I'm going to put my little logo just there. So if I just go on to File, Import, Image, select Image, I've selected my image, can play about with the sliders and Insert. Obviously it's way too big, but I'm going to click it. I'm just going to say this is on the top silk layer, and I should be able to resize it a little bit by just going, say, 16 by 16 perhaps. That'll do. I can just put that just there, so when I now click on the 3D, we've now got the logo just there. Something I also like to do is put the GPIO pinout reference on the back of the board. It can sometimes save looking things up in the future if you're playing about with it. Okay, so I've got the image. I'm just going to play about these settings a little bit. Press Insert. Okay, again, way too big. Let's move that onto the bottom silk layer. So it's obviously mirrored it, and let's make this a bit smaller. And now we're clicking 3D. Okay, there we go. We've got a nice little GPIO layout on the back of the board. Okay, one last step, and this is the bit where I like this sort of software, is I can just go on to Root, Auto Root. If you've got it installed, it is a little bit quicker. I've not installed it right now. It's failed to find it, so I'm going to click on Cloud and just say Run. There we go, it's not failed on NA. So now if we have a little look at this, we can see that all the connections are there. What I like to do is just go through each of the pins and sort of follow the traces around and make sure we are happy with the layout. And again, if we click on 3D, we should be able to see the traces. Yeah, we can see them just there. And if you're not happy with them, you can always rewire it manually. Okay, so as we can see, it's pretty much the exact same layout, apart from I've got extra components on there because it's easier to fit them in the PCB than it is to do all the jump wiring. So now we've got that, we need to put this to a format that we can then send to PCBWay. So if we go on to fabrication, I want to just say PCB Gerber file. Yep, thank you for reminding me to save it. So fabrication, Gerber, yes, I will do this. It's going to make sure there's no clashing. So happy with that. I can now say generate Gerber. It's now download this file. I found it in my downloads folder. So our next step. Okay, now we've completed the transmitter. I'm going to quickly do the receiver one as well. Now I can cheat a little bit on this one. I can go into the previous and grab these two components, copy, paste. There we go. So it just saves me looking through the library for them. And I also want to grab a servo. So again, I'm going to nip into the library. I'm just going to type in servo 3-pin. Yeah, that'll do. And then I can slowly move these round to basically match this board that obviously we've already seen. You know, I've got the DF player, got the ESP, got the speaker, etc, etc. So I would need a couple of pins. Again, I can use the common library for the pins. There'll be my pins for the speaker, pins for the battery pack, and so on. And I can slowly build this up. You know, I can rotate this round. Again, I can copy and paste this now for each of the 3 servos. And I can slowly connect up. And the last thing I really need to make sure this is all ready is go onto the library and just choose the DF player. What have we found? DF player mini. See if that comes down a bit more. Yeah, that looks fine. So I can place that. Well, that's quite big compared to other things. And then I can slowly connect it up. Now I've already seen that wiring diagram. So in good Blue Peter fashion, here's one I made earlier. So you can see I've taken the wiring, I've matched it over, but while I'm here, I've added a few extra little bits. I've got the speaker connector, but also it's got these DAC for direct connection, so straight into an amp. So I've added a pin out for that one. Won't use it on this project, but maybe in the future. Because I've got an extra pin, I've put an optional servo just in case I want to put something else to it. Also, someone suggested me putting an actual LCD screen inside the little droids. So I've also, while I'm at it, I've added something that hooks up to the data and clock pins, and also the voltage and ground, because while we're making a PCB, it literally takes a couple of minutes to add some extra components. On this one, I've also put a voltage regulator in. Because this is driving the servos, I might actually want to put a bigger battery pack in there, and I don't want it blowing the ESP. So this little battery, this voltage regulator, is just a 3-pin thing. I've got voltage in, which is going to come from the battery pack. So the batteries are going to feed the voltage in, and then that's going to feed its current directly to the voltage of each servo, and then that's connected up to ground. So it's basically pumping 5 volts into the system, and then the output of this voltage regulator is going straight into the 3-volt in. So notice I'm no longer connecting the 5 volts, this is just getting its power from the 3 volts. So if you try to power this from a USB socket, it's not actually going to run these servos, they're no longer on the same connection, and it's all hooked up to the ground, and that's it. So again, it took a bit more doing, but if you want me to, I can upload this Gerber at some point. So I've gone through the exact same process, I've converted to a PCB, I've spent quite a bit of time laying this out, making sure they're just right, putting the pins where they need to be, adding the various little labels, and then we can see this is what it looks like, complete with the pin out on the back. Okay, so I'll stop that there. Now obviously in this video we've just quickly made the actual PCBs themselves. In the next video we'll look at how we can upload, how we can actually make them, solder them, and then modify the code so it's now more featured. So again, please remember to like, subscribe, positive comment below, and I'll see you in the final video, which is part 5.